Hi guys, we're going to be graphing parabolas today in the form y equals ax squared. These are called quadratic functions or quadratic equations. And we're going to be learning about the vertex, a minimum, a maximum, whether it opens up or downward. And we're going to talk about the vertex and the axis of symmetry, or some people call that the line of symmetry. So just some general vocab here so you know what I'm talking about. The graph of a quadratic function is a U shape called a parabola. And you can see there's one picture to the right. It's black. And you can fold a parabola. It is a symmetrical shape. That fold line divides the parabola in half exactly, and that is called the line of symmetry or the axis of symmetry. Same thing. I'm going to abbreviate that as LOS. In this picture over here, you can see that the vertex is here, the lowest point of the parabola, 0, 0. And the line of symmetry is the red dotted line, and we're going to call that x equals 0 because it's a vertical line right at 0. The highest or lowest point of a parabola is called the vertex. You can see in the picture I've highlighted both of those green. It is the only point that is not symmetrical. In standard form, y equals ax squared plus bx plus c. That's for all parabolas or quadratic functions. And today we're just going to be graphing at y equals ax squared. If a is positive, so if in standard form this is a positive number right here, the parabola is going to open up and the vertex is called the minimum. So you can see a picture over here, here's one that opens up. It has a positive a for sure. And the minimum is here, the lowest point on the graph. And if in standard form that a is negative, the parabola opens down and the vertex is called the maximum. And you can see that over here. This minimum or this maximum is the highest point on that parabola, which is why it's called the maximum. Both of these points are the vertex. And this vertex is negative 3, 1. And this vertex is 2, 0. And the line of symmetry would be the fold down right down the center. The line of symmetry for the one on the left is x equals negative 3. The line of symmetry for this one on the right is x equals 2. You must have the x equal, otherwise it's just a number and it's not a line. So I've got some that you can try here. If you want to push pause, I'd like you to tell me whether it opens up or down, the vertex, the line of symmetry, and if it has a maximum or a minimum. So this point right here is called the vertex. That vertex is 3, 0. The line of symmetry is the fold down the center. That is x equals 3. This vertex is the minimum on this parabola, and it opens up obviously kind of like a smile. Over here, this vertex is negative 4, 0. The line of symmetry is a fold line right down the middle. That is x equals negative 4. It has a maximum because the vertex is the highest point on the parabola and it opens downward or makes a frown. Okay, it has a negative a. All right, so y equals a squared is what the book talks about a lot. It asks you to compare each one of the graphs that you graph to the parent function. This is the quadratic parent function. So in a parent function, the 0 is going to be in the middle. When I plug 0 here, y equals 0 squared. I'm plugging this number in for x. I get 0. So you can see over here I already have it graphed. The vertex is 0, 0. And I put the vertex right in the center because these two are going to be symmetrical on the y, and so are these outside two. So I'm going to use 1 and 2. And negative 1 and negative 2. You can see that they're symmetrical here and here as well. So if I plug 1 in for x, y equals 1 squared, that's 1. That means that this is also 1 because they are symmetrical. And if I plug in 2, y equals 2 squared, that's 4. So these two are symmetrical. So you can see 1, 1 is my first point. Having trouble with my pen. There we go. And 2, 4 are my second sets. And this is the parent function. Okay, the vertex is 0, 0. You can see that right here. The line of symmetry would be x equals 0. The domain would be all real numbers because I can plug any number I want in for x. Whatever number I plug, though, I have to be willing to graph it, which is why I picked the most simple numbers that I know. And the range is 0 and above, so that's y is greater than or equal to 0. All right, so let's give this one a try. We're going to use the same numbers. I'm going to start in the center with the vertex. So 0, I'm going to try 0, probably 1 and 2 here. Yep, I've got an integer here, so 1 and 2 are best, which makes this -1 and -2. So when I plug 0 in there, y equals 2 times 0 squared, that's 0. When I plug 1, 2 times 1 squared, that's 2, which means this one also is, because those are symmetrical. And y equals 2 times 2 squared. Well, 2 squared is 4. 4 times 2 is 8. That means this one is 8. So if I graph it over here, 0, 0 is in the center. 1, 2, -1, 2, 2, 8, and -2, 8. So let's try to hit all these points with my slate. Try to make that bottom rounded. You don't want the bottom to be pointy. That is a different graph if it's pointy. Okay, so you can see very clearly from the picture that the vertex is 0, 0. You can also see that from the table. The line of symmetry is x equals 0 because I could draw my fold line right down the middle. The domain is all real numbers, and the range is y is greater than or equal to 0 because it's the 0 and it's above. How it compares with the parent function? Well, there's a couple things here. If I draw in the parent function, the first point would be here and here, and 2, 1, 2, 3, 4, 2, 1, 2, 3, 4. So you can see that it's kind of stretched up. This point is stretched up like someone's pulling it from the top. Okay, so if it's a stretch, it's more narrow. This green, or the one that we just graphed, is narrower than the parent function. Okay, and since it is narrower, it is a stretch. Another way that I can tell that it's a stretch is because a equals 2. So a stretch would be 1 or bigger, or -1 or smaller. So if it falls in between -1 and 1, it's a shrink. And if it's outside that small parameter, it's a stretch. Like someone is standing up at the top of it, up here, and grabbing a hold of the edges and pulling up, stretching that parabola, making it skinnier than the parent function. Okay, and I don't want you to graph the parent function each time. I'm just trying to show you that it is smaller or more narrow than the parent function. Okay, here I've got a 1/2 here. Y equals 1/2 x squared. We'll do this one together too. So again, I'm going to start with 0, 0 right in the center. So if I plug in 1/2 times 0 squared is 0. You're going to notice that most of them, actually all of them that don't have the bx plus c, have that vertex of 0, 0. So instead of 1, because this has got a denominator of 2, that would give me a fraction. I'm going to use multiples of 2. So 2 and 4. So since I went up 2, I'm going to go back 2 and back another 2. So they're symmetrical across the top. So they will definitely be symmetrical here as well. So let's plug 1/2 times 2 squared. Well, 2 squared is 4. Half of 4 is 2. So if that's 2, so is that. And 1/2 times 4 squared. Well, 4 squared is 16. Half of 16 is 8. So these are both 8. So if I graph it, 2, 2, -2, 2, and 4, 8, and -4, 8. Let's try to draw this and hit all the dots and not make it pointy on the bottom. Hey, that's not too bad. Hey, this one looks wider. It is wider. This is wider than the parent function. The parent function is in here somewhere inside it. So if it is wider than the parent function, this is called a shrink. And again, you can tell from the picture that it is a shrink. Like someone is standing on top up here, pushing them down. If it's like pushing it down, it's making it a shrink. I can also tell because the A is 1/2. And if the A is between -1 and 1, which 1/2 is, that makes it a shrink. Okay, so I can go down here and answer these questions. The vertex is 0, 0. The line of symmetry is x equals 0. Their domain is all real numbers, and the range, let's see, it was a smile, so x or y is greater than or equal to 0. All right, press pause and you try this one. I will warn you because it has a denominator of 3 that you're going to want to use 0, 3, and 6, and then -3 and -6. Press pause and come up with the y's, graph it, and answer these and see if you get this right. So if I plug in -1/3 times 0 squared, that's 0. I'm kind of expecting that. If I plug in -1/3 times 3 squared, well, 3 squared is 9. -1/3 times 9 would be -3, which means that this one is also -3. And -1/3 times 6 squared, that's 36. -1/3 times 36 is -12 on both sides here. Again, these are both the same number. Also, something different about this one, if you notice, this A in the very front is negative. I know that this is going to open downward like a frown. Okay, I know that. If it doesn't, something's wrong. So let's go ahead and graph these points. So 0, 0, 3, -3, 1, 2, 3, 3, -3. And the center point goes off the graph a little, but that's okay. 4, 5, 6 down 12, and 4, 5, 6 down 12. So there's my picture. You can also tell that this one is wider just by looking. I mean, the parent function here would be 1, 1, 1, 1, and 2, 4, 2, 4. Whoop, I scooch over 1. But it's still wider. 2, 4, right there. Oh, trying to erase it. I don't have anything there. So it will be right there. So you can see that this graph is wider. Since it is wider, wider is a shrink. I can also tell that it's a shrink because of the A. The A is -1/3. And that makes it a shrink because it's between -1 and 1. If it falls in between there, it's a shrink. Okay, it's a shrink. My vertex is 0, 0. My line of symmetry is x equals 0. My domain is all real numbers. And my range this time, because it's opening downward at 0, is y is less than or equal to 0. Okay, give this one a try. Press pause and try it without me, and then I'll come back and do the answer. We're back to an integer in the front, so using 0, 1, and 2 is perfectly acceptable. You won't get fractions. So we'll use 0, 1, and 2, and -1 and -2. Sorry, my dog is barking. So y equals -3 times 0 squared is 0. Y equals -3 times 1 squared is -3. And y equals -3 times 2 squared is -12. I'm going to be off the graph a little again. I know that it is opening downward because it has a -a. So I know that it has a downward open or a frown. It's going to look like that. I know that because this A is negative. Okay, so let's graph it. We've got 0, 0, 1, -3, -1, -3, and we need to go down just a little bit more, 2, -12, and -2, -12. So it looks pretty skinny, don't you think? This one is called a stretch. Okay, or it is more narrow than the parent function. Okay, and it's kind of hard to tell because the parent function would be here, 1, 1, and then 2, 4, but 2, 4 is right here. That's inside of it, so it is more narrow. Again, another way I can tell is that the A is -3. And remember, if it's between -1 and 1, and here, this area is called a shrink. And if it's outside, like -3 is over here, that would be called a stretch. The vertex is 0, 0. The line of symmetry is x equals 0. All real numbers for the domain, and y is less than or equal to 0. Starts at 0, and all the numbers below apply. Okay, so if you have questions about shrink or stretch, you can pull up Desmos and look for the pattern. Okay, if you go to Desmos.com and look at the graphing paper or the graphing calculator, if you graph the parent function, which is y equals x squared, and then you throw some numbers in here for a, like 2, 1/2, you'll see how it changes. You'll see how it changes. And I've got some notes here for you that you can write down if you want to. So a shrink falls between -1 and 1. It doesn't include -1 and 1. It falls between it. And a shrink, and it's wider. Shrink and wider goes together. Okay, and then on the opposite side of that is called a stretch, which we were talking about that before. A stretch is narrower. Okay, and it falls outside 1 and -1, and it includes them as well. So I have a little graphic here for you. Oh, I erased it. So between -1 and 1, not including, so those should really be open. Let me open those instead of closing them. So open here, an open circle here, and an open circle here. Narrower. So if it's narrower, the A that is, this is a stretch. Okay, and then if I do my shrink, that would be including 1 going bigger. That would be including -1 going smaller. So this is wider, so this is a stretch, and so is this over here. So that graphic is a good way to remember. I have a hard time, that graphic is a good way to remember. I have a hard time remembering which is which. This one is a shrink, not a stretch. So is this a shrink. Okay, so just that small portion between -1 and 1 is your stretch, and then outside that area, everything else is a shrink. Okay, so make sure you write that down so you have that, either the definitions or the graphic, whichever one you like better. That totally works. Okay, I have more, but I'm ready for you to try the big ideas assignment. So if you have already done this assignment, you're done for the day. Some of you did this before spring break. If you have not done this assignment, you need to go to Big Ideas, go to the resource portal, Big Ideas, and go to Assignments. And you'll find the assignment for 8.1. And I want you to do that. And make sure you submit it online. I don't need any paper submitted. You're going to do all the work at your house and then submit it online, and I will grade it online. Okay? If you have any questions, email me, and also I have office hours between 12 and 1 every single day for your class. Thanks very much. I hope you enjoyed 8.1. It's nice to get back to math a little bit. Take care.